Today we're gonna show that counting measure is a measure. So our topic is counting measure. Okay, and it is very tricky to prove it. Most of the time book they just omit this proof, but we are gonna show that. So again, let x is a s is a sigma algebra and the power set. Okay, so then let mu of e is number of points in E. Okay, so we need to show that mu E is a measure on axis. So prove. So first, clearly measure of phi is 0 because there is no point. Because there is no point in empty set. Our actual thing to prove is measure of union of k is equal to 1 up to infinity. Ek is actually sum of k is equal to 1 up to infinity. Measure of Ek, and the condition is where Ek are pairwise disjoint sets in S. This is like very important. Like we should not forget this property because this is everything. Okay, pairwise disjoint. So how can we show this thing? So first, if E and F are disjoint sets, okay, then by the second property of measure, E union F is measure of E plus measure of F, and then by induction we have measure of union of k is equal to 1 up to n. Ek is actually sum of k is equal to 1 up to n measure of Ek, right? This is by induction. So what we get for all n, we get sum of k is equal to 1 up to n measure of Ek. I'm going to rewrite this for a reason. K is equal to 1 up to n Ek. Now we know about the monotonicity, that Lebesgue measure have monotonicity. So somehow the measure they also have monotonicity. So we know that union of k is equal to 1 up to n Ek is contained in union of k is equal to 1 up to infinity Ek. So this sum, that's how measure of union of k is equal to 1 up to Ek is lesser or equal to measure of union of k is equal to 1 up to infinity Ek. So our equality becomes k is equal to 1 up to n measure of Ek is lesser or equal to union of k is equal to 1 up to infinity Ek. Now this is an upper bound of this partial sum. So what we can say for k is equal to 1 up to infinity, we can say that sum of now k is equal to 1 up to infinity measure of Ek is lesser or equal to measure of union of k is equal to 1 up to infinity Ek. Okay, so that's we showed, but now we need to show other way around. Means we need to show measure of union of k is equal to 1 up to infinity Ek is less than sum of k is equal to 1 up to infinity measure of Ek. Okay, there's remaining to show, then we will have equality. So how we can show that? So to see that, So first of all, if I want to show a is lesser than b, then it is, you know, obvious, or it is, you know, kind of obvious that b should be less than infinity. If b is infinity, then there is nothing to prove. So that's how we will assume. Assume that sum of k is equal to 1 up to infinity, measure of ek is less than infinity. Okay, now if measure of less than is infinity, if the sum of a series is less than infinity, this means that the series is gonna be, you know, convergent. So if series is gonna be convergent, okay, then what does it mean? Then it means that if this is, assume if the series is convergent, this means that there exist okay, n belong to natural number that we know from the basic real analysis, such that for all k, all those value which are greater than k, this, you know, element of the series will be 0. So measure of ek is actually 0. Now if measure of ek is equal to 0, what does it mean? This means that definitely then ek has nothing. Okay, then ek is actually empty set. Okay, then ek is actually empty set. So now, okay, so ek is empty. Okay, so now because measure of ek is equal to 0 for all k is greater than n, what we can say about measure of union of k is equal to 1 up to infinity ek? So definitely, so this is measure of union of k is equal to 1 up to n ek, because the values that are all greater than n, the measure is 0. So definitely measure of union of k is equal to 1 up to infinity, because for all k is greater than n, measure of ek is 0. So if now, because k is equal to 1, so now we know that k is equal to 1 and ek are disjoint sets, so I can write down this sum of k is equal to 1 up to n, measure of ek. Now again I can extend that to infinity, because after n is greater than k, it is 0, so it doesn't affect ek. Hence we saw that, okay, this union of k is equal to 1 up to infinity, ek is nothing but this is sum of k is equal to 1 up to infinity, measure of ek. Thus measure mu is a measure on xs, and it is called a counting measure. And thank you.